Hi guys, we have a question here that I want us to go through together. It is simple actually. Four identical cells, each of EMF E and internal resistance R, are connected in series with an external resistor, uppercase letter R. Write an expression for the current I flowing in the circuit. This is a case where we have up to four cells with internal resistance powering an external resistor R, and we want to know the current that is flowing in the circuit. For cells in series, when cells are connected in series, the total EMF of the cell is the sum of each of the EMF of the cell. The total EMF of the circuit is the sum of each of the EMFs of the cell. In this case, we have four cells. So the total EMF T for total will be equals to E1 plus E2 plus E3 plus E4 for four of the cells. And we are told that each of the cells has an EMF of E. So we can replace E1, E2, E3, and E4 with the letter E, which means we'll have E plus E plus E plus E, and that is 4E. So the total EMF ET will be equal to 4E. Remember, we are trying to write an expression for the current. There are no figures here. We just want to write a formula for the current I. Similarly, the resistors, the internal resistance of each of the cells will also be in series, so that RT, lowercase letter r, for internal resistance, total internal resistance will be R1 plus R2 plus R3 plus R4. And remember, each of the internal resistance is given as R. So we have 4R altogether, giving us the R total to be equal to 4R. Now we know the total EMF and the total internal resistance. Let us now write a formula that connects the EMF of a cell, the internal resistance, and the external resistance in a circuit. According to Ohm's law, the EMF is equal to the current times the total resistance. EMF representing voltage, I for current, while R plus R representing the total resistance in the circuit, both internal resistance and external resistance. We are looking for R, that's what we are writing an expression for. Sorry, I, that's what we are writing an expression for. So if we want to make I subject of the formula, we need to divide both sides of the equation by R plus R, so that I will be equal to E all over R plus R. But one thing to note here is that since we have more than one cell, it means we'll be looking at the total EMF and the total internal resistance and not just one of them, right? So we can rewrite this formula, or this expression implies that I will be equal to E total all over R plus R total. What we just need to do is to substitute the values of E total and R total into this formula, or rather their expressions. E total is 4E, R total is 4R, so that the current becomes I equals 4E over R plus 4R. So this is the expression for the current we are told to look for. If figures were given, you just plug in the figures into this formula and you will get the value for the current. So this is the answer to this question. Very simple and straightforward. As a follow-up to this exercise, I want you to try this. For the exercise above, that is this exercise, if each cell has an EMF of 3 volts and a current of 1.5 ampere flows through an external resistance of 4 ohm, what is the internal resistance of each of the cell? So as a follow-up to this question, figures are now given and your task is to find the internal resistance R of each of the cell. When you get the answer, please put it in the comment section and I will be there waiting for you. Thank you for supporting Knowledge Base, and please like and share our videos. That way you keep encouraging us to make interesting and educative content. Once again, thank you for watching and hope to see you in our next video.